Coach J coming to you live, 5.3 and 5.4. It's Friday afternoon. It's literally 5 o'clock on a Friday afternoon. I love y'all. I'm just telling you, I love y'all. We're going to get after it today. We got 5.3 to 5.4. Man, excited about today. Excited about it. Hey, I would get out your review at this point. We're going to tone down Welcome to the Jungle here. 5.3 and 5.4, I would take that out if I were you. The review, if you have not gotten that, I'm actually going to post it right now. It's actually at the bottom of this page. If you actually go look downward. In fact, I think, let me see if I got, actually don't have it up right now, but if you go through and check it out, it's actually at the bottom of this page, and you'll see the answer sheets. The answer sheets are also posted there. Please check this podcast out. At the beginning, I'm going to hit a couple problems that may not be on the review, but that definitely need to be understood and known. We'll get underway. All right. Sound good? Yes. Let's go. All right. Let's get it going. Welcome to Coach J's review. Let's get it going. All right. Here we go. All right. All right, now, as far as this goes, we have a couple of problems we want to hit on. All of these from 11 all the way down through the end, 21 or 20 or whatever it may be, are involving problems that you need to know for your test. Now, a couple of ones that are not on here that are important. Let's say that we had one that was the sine squared of x minus sine of x. What the heck equals 0, right? That could be a good one. You could also do one. Well, you could do a ton of different things, but this is a good one just to kind of go off of, okay? Another one to just kind of look at. In fact, tomorrow, if you want to, ask me about this one. Cosine squared of x plus cosine of x minus 6 equals 0, right? Or even better yet, let's actually back that up a little bit. I think we had one on the today that was like plus 2x plus 1 equals 0. We'll do that one too, okay? Now, when we come to a problem like this, we're looking at first trying to factor, aren't we? It's the goal. We're trying to factor here and here. And when we factor, we're trying to first figure out, is there something that, first of all, everything's got to be on one side, right? But is there something that I could take out of both of these? Well, I could actually take out a sine of x. When I take out a sine of x, I wonder, is there anything else that is left over? Well, taking out a sine of x, I look at the first one and recognize that I've actually got a sine of x left over of the first one. Remember, I take out a sine of x because they're in common. Notice on the bottom, between the three values here, here, and here, these three are not, they don't have something in common, so we can't take that out. But up on top, we do, and when we take out a sine of x, we have sine of x on the outside, and on the inside, we have sine x minus 1. Now, since we've got it factored out, such as like so, okay, we can set both of these equal to 0 and look to solve. So sine of x equals 0, and sine of x minus 1 equals 0. And remember, just a heads up, 5.3 and 5.4 HW, it's a good way to look right there, okay? It's a good way to look. So I set them equal to 0, sine of x equals 0, and I add 1, sine of x equals 1, okay? So where is sine of x equal to 0? And then also where sine of x is equal to 1. So on my unit circle, that's where I go, right? I find where on my unit circle is sine of x equal to 0 and sine of x equal to 1, okay? We'll put this over here on this side, down below. So on the blue, I'm going to put my answers here. I know that sine of x equals 0 at 2 places, right? It'll equal 0 at, maybe this is y, right? Where y is equal to 0. It'll equal 0 at 0 and pi. And remember, where is sine of x equal to negative or positive 1? Well, sine of x is equal to positive 1 at pi over 2. So we've got 3 answers, boom, boom, and boom. And if I were to ask you what are the answers between 0 and 2 pi, these are the only answers that I would provide. However, if I said, what are the answers? Just give me the answers with no range attached to it. I would make sure that I would also add on the ends of this 2 pi n because of the coterminal spot that we've got to be in, okay? So 2 pi n, we've got to add that and go from there, okay? All right, look at the bottom one. This one's a little different. Again, I told you can't take out something that's in common. But what I can do is replace the cosine with an x. So I've got x squared plus 2x plus 1 equals 0. So I factor out factor out, and I say, okay, what two numbers multiplied give me 1, but when added give me 2? I've got x plus 1 and x plus 1, okay? So what we could do now, since we've got it factored out, is plug in a cosine back in for x to get cosine of x plus 1 and cosine of x plus 1 equals 0. So I set both equal to 0, and since they're the same thing, we say cosine of x plus 1 equals 0 and subtract 1, to where then cosine of x equals negative 1. So where is cosine of x negative 1? Well, I can look and see where is the x value, just like what sine would be in the y value. Where's the x value, negative 1? And I know that there's only one spot, and that would be at pi. Okay? That would be at pi. And right there, that would be your answer. Okay? That would be your answer. And I'm going to come back to a couple of these too, because I think this will be important. Now, this right here, again, these are the answers down here. I would make sure I'd also add 2 pi in here, right? I would want to make sure I add 2 pi in to that spot on that side, okay? All right, very good. A couple other ones that I want you to kind of just have here, and ones that I want to make sure that you hit on. We might have about 1 or 2 of these on the test, and so I want to make sure that you at least have those addressed. And that's this. Let's take a look at one. Let's take a look at like sine square root of 3. No, I'm sorry. Let's go backwards. Let's go 2 sine of 2x minus square root of 3 equals 0. Now, again, I'm trying to get sine by itself, right? But remember this 2x, we freeze, right? So we're going to add square root of 3 on both sides, add square root of 3 on both sides, to where these cancel. And we have now a square root of 3 equals 2 sine of 2x, okay? So getting sine by itself, we divide by 2 to where sine of x, 2x, equals square root of 3 over 2. Now, remember that the 2x is frozen, right? We want to freeze this. We use it at the very end. So the question becomes, where is sine going to be square root of 3 over 2? So that's the question, right? It's really the question there. And so what we'll do is we'll come on the unit circle. And here's our answers here. And we realize that square root of 3 over 2 is found in sine 2 spots, right? The first spot is pi over 3. And the second spot is 2 pi over 3. And in this case, since we have it here, we'll add 2 pi n. The only time I would not add 2 pi n, I would add pi n, only when we talk about tangent and cotangent, okay? Tangent and cotangent refers to plus pi n, okay? So now I've got the answers of pi over 3 plus 2 pi n, and so on and so forth. But here's the kicker. We've got to now set these equal to the 2x. Remember, that is the last part. Remember that, okay? Last part. Big, big time. So what I'm going to do now is I'm going to set both of these equal to 2x, okay? And to do this, we're going to divide by 2. Divide by 2. And again, I'm going to do this. Once I do it to 1 right here, I have to do it to all of them, okay? So let's do the top one first so you're not confused. And when I divide by 2, if I see a fraction, the same thing as multiplying by 1/2, right? So we're going to multiply by 1/2 here, divide by 2 here. Same thing, right? And you could divide by 2. These cancel out to get x by itself, right? These actually end up canceling each other out to where up here, this now produces the top part. Now kind of go to this top answer. That's pi over 6 here plus pi n. So my first answer, pi over 6 plus pi n. And the second answer down here is 2 pi over 6, so the 2's could cancel, so pi over 3 plus pi n, okay? Right here, right here. Again, that's answer 1 and that's answer 2 for what we're looking at here. Remember, the key part is that this 2x out here is always the last part. Whatever's attached, right? If I had tangent of x over 2 equals 1, right? The x over 2, because that follows and is attached with tangent. Now, if it was unattached, that's different, right? This negative square root of 3 right here up on top was not attached to sine, so that's a little different. We added it over and then went from there. But over here, since the x over 2 is, we'd find where's tangent 1 and then find where x is over 2. In fact, I want you to do that one and then check me in class or in the morning if you need some help on that one there, okay? Last one before we get to the complete review, before you kind of go forward, I'm trying to give you some of the harder ones. If I had cosine of 2x minus 1 equals 0, check that one out. See if you could figure that one out. Try to see another one that we could maybe do. 2 sine squared of 2x minus 1 equals 0. Let's do this one, okay? Last one here. So this time, again, we're going to freeze the 2x. We're going to add 1, okay? Add 1. These cancel. So we got 1 equals, or 1 on the right side. On the left side, we divide by 2, right? So, in fact, let's just rewrite this here. 2 sine squared of 2x. We're going to divide by 2. What I do to one side, I do to the other. So what I've got here is sine squared of 2x equals 1/2. Okay? So where is sine going to be 1/2? Well, sine will be 1/2 at a couple of different spots. And as I recognize this, this might be a little off, won't it? Let's do this. Let's change this 4 to a 2 real quick. I'm sorry, y'all. I was trying to make this one up on my head, off the top of my head, because this is a tough one. But what we'll do is we'll square root both sides, okay? Because to get sine by itself. So sine of 2x equals 1 square root of 1/4. Which, what's the square root of 1/4? Well, that's the square root of 1 over the square root of 4. So that would be 1 over 2. So, and by the way, when we have square root of squared, we have to have plus or minus. So we could say this. Where is sine of 2x equal to plus or minus 1/2? So how do we find that? Well, we're going to go straight to the unit circle on this one. And we're going to figure out where is sine 1/2. Well, we could find out the 1/2 part by, I believe it's pi over 6. So anytime if it's plus or minus, we're going to label all of them. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, okay? All of those together. Because it's sine, we're going to add 2 pi n. Add 2 pi n. All of these, okay? 2 pi n, add 2 pi n. Now, without the 2x here, that would be my right answer. But I've got this 2x here, right? I told you this one was tough. So what I'm going to do is I'm going to set this 2x equal to every single one. So I'm going to set it equal to pi over 6 plus 2 pi n. And I'm going to multiply by 1/2 on both sides. 1/2. So what happens here is this would be canceled out, going like a freight train, going like yesterday. This would be pi over 6 times 1/2 is pi over 12. Plus, 2's would cancel, pi n. Now, you could keep going through that. This is, again, the modified answer of here. But if I did this modified answer, guess what? The same thing holds true. I'm multiplying by 1/2 and 1/2 to get 5 pi over 12 plus pi n. Sorry, pi n. Answer 2. Answer 3. 7 pi over 12 plus pi n. Answer 3. Answer 4. So it'd be 11 pi over 12 plus pi n. Again, that would be number 4. That's a really tough one. That's a lot entailed. If you get that, then you're good to go. The big thing I wanted you to hit on is understanding that 2x part, because again, that might end up being on the part of the test come tomorrow or come Monday, okay? All right. Let's see here. Now let's go through a couple problems here, okay? See if we can do it here on this side. Cosine squared equals 3 sine squared. Okay, let's do this one. Now, anytime we have different languages going on with cosine and sine, what we're trying to do here is trying to figure out what I can do to get those on the same page or same level, okay? So let's subtract this to both sides, the sine squared of x. All right, canceling, it should be 3, I'm sorry. Canceling on both sides. Getting 0 on my right, and on my left, I have cosine squared of x minus 3 sine squared x, okay? Now, is there anything I can do on that left side to be able to speak the same language? What I could do is change cosine or sine, because I remember that one of my identities was sine squared x plus cosine squared x equals 1, okay? So what can I do to rearrange this? Well, I can remember to get cosine squared by itself, I can subtract sine squared x to both sides. This cancels, getting me cosine squared of x equals 1 minus sine squared x, okay? So this would end up being plugged in for that right there. So I've got right now 1 minus sine squared x minus 3 sine squared x equals 0. Now subtract both to get 1 minus 4 sine squared x equals 0. And now we're going to solve, okay? So we got subtract 1. This looks a lot like the problem we just did, didn't it? Subtract 1, divide by -4. Right? We're trying to get it sine by itself now. So we get now sine squared x equals 1 over 4 because we have two negatives. We square root. The square root of 1 is 1. Square root of 4 is 2. So we would say then sine of x equals 1 over 2. And when we square root a squared, the other side produces a plus or minus. So the question is where's sine? Positive or negative 1/2? So I look and see where's sine positive negative 1/2, and I recognize it's the same ones we just said, right? So pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, right? Because of coterminal, unless it tells us differently, right? 7 pi over 6 plus 2 pi n, 11 pi over 6 plus 2 pi n. Okay? 1, 2, 3, and 4. Okay? All righty. That was that one. That was probably one of the more difficult ones. The ones that I've hit on right now are tricky, okay? They are a little tricky there. Now, this one actually did say interval. So because it did say interval, I didn't need to put the 2 pi in. But just so that you're made aware of that, that's why I'm wanting to do that there, okay? All right. Okay, this one you should be good on. This is where we're going to just subtract 1 to both sides. So where's tangent of x equal -1? It should be Gucci on that one. Remember, you're going to add pi in at the end because there's no interval there. Over here on the bottom one, or I'm sorry, number 12, this is where I would add 9 to both sides, right? Getting 3 tangent squared of x equals 9. Divide by 3. We'll do this one just so we can kind of go from there. So we got tangent squared x equals 3, right? Square root both sides. Where is then tangent of x equal to, and again, square root is squared, I get plus or minus the square root of 3. So when I look at where is tangent plus or minus the square root of 3, I know that that's going to be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And since this is all tangent, we would literally just add pi in, okay? Now notice we have a couple of answers that we don't actually have to repeat because once we add pi into this, we get here, right? So really the only two I need are here because if I added pi in, I would get from here to here. It's a little redundant, but I'll take it. You'll get the same answers. You're just saying the answers twice there. Over here on same thing, 14, very similar to 11. We want to get everything on one side by subtracting the square root of 3 and adding sine from the right to the left. So we would have on the left side sine of x minus square root of 3 plus sine of x, right, equals 0. Okay, once I take this to the other side, I would add to get 2 sine of x minus square root of 3 equals 0. That's where I would, in this case, add square root of 3, divide by 2, right? And then I would just solve it like I've been doing with a lot of these problems here, okay? All right, let's keep going. Actually, I think 14, oh yeah, 14 we already did, that one's in there, right? This one would be simply adding 3, dividing by 4, right? This would be where cosine squared of x equals 3 over 4. I would square root both sides. Again, here's where a lot of people are struggling. Here's where we get cosine of x equals plus or minus, because the square root is squared. The square root of 3, and what's the square root of 4? That's 2, right? Whereas cosine of x equal to plus or minus the square root of 3 over 2. And so that would be, again, I'd look at my unit circle, and that's where I would get all my, I think, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And remember, I would add 2 pi in for each of these, okay? Add 2 pi in for each of these, okay? Because there is no interval there, okay? Now let's go to sum and difference a little bit. I think we got these a lot better, so I don't think I have to go too much into this, okay? But remember, when we look at this, we're looking at 75 degrees, and we're trying to identify where on my unit circle is tangent of 75 degrees, okay? And, you know, that's a good question because we're trying to look and see, and there's no 2. But we know that we could add 2 together, don't we? That are on my unit circle, or subtract 2 together to be able to get to where we have the problems necessary. We have the problems that we need here, okay? So we could kind of go to 75 and say, okay, the tangent of 2 angles, what 2 angles add up to be equal to 75? Well, we could do 30 and 45, right? And in doing so, we could say, okay, I understand that I can't distribute tangent to each, right? I just can't do it. Remember I said I think I'd haunt you and your children's children and your children's children's children, right? Yes, you, Alex. I hear you. Yes, even you. And so what I have now is tangent of u plus v equals tangent of u plus tangent of v. This is what you will get this, okay? You will get this. Over 1 minus tan u tangent v, okay? All right, so we've got that there. Now, what is u? Well, u is the first angle, and then v is the second. Here, it doesn't matter which one it is because you get the same thing. But you'll have then tangent of 30 plus tangent of 45 all over 1 minus tangent of 30 tangent of 45. And so what we're trying to do in all of these is we're just trying to solve and say, okay, what is tangent of 30? Well, we remember on our unit circle that we have 3 different values, right? We have a 30, 45, and 60 degree angle. At my 30 degree angle, we get square root of 3 over 3. At my 45 degree angle, we get 1. And at my tangent of my 60 degree, we get square root of 3. So tangent of 30 degrees is actually square root of 3 over 3, okay? Now, what about tangent of 45? That's a key here. Tangent of 45 is 1. So we say square root of 3 over 3 plus 1. And then on the bottom, we get 1 minus, again, tangent 30. That's going to be square root of 3 over 3. And I keep it in parentheses. This whole thing, keep it in parentheses so I don't try to mess this up, okay? Because this is going to be multiplied with a value of 1. Well, PEMDAS says, okay, PEMDAS is my friend, okay? I have a shirt, PEMDAS is my friend. What is square root of 3 over 3 times 1? Well, that is square root of 3 over 3. So we got right now 1 minus square root of 3 over 3. And then on the top, we get square root of 3 over 3 plus 1. So now we're trying to find what is my common denominator within those ones. Well, that's where on the top we look and say, all right, if this has a 3, this one's got to have a 3. If I do it to the bottom, I also have to do it to the top. Same thing here. If I do it to the bottom, I also have to do it to the top. To where my answer on the top would be, because I could combine now because of that common denominator, square root of 3 plus 3 over 3, all over 3 minus root 3, all over 3, right? So we flip this to the top. We multiply by the reciprocal. Remember that 3 minus root 3 and 3 square root of 3 plus 3. We can't simplify, right? So we just are left with square root of 3 plus 3 all over 3 minus square root of 3. Now, here's the deal. I said on this one, okay, I did say on this one you do not have to rationalize it. You must get it here. However, if you're really feeling gutsy, and I might throw a little challenge question out there, hint, 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 hint. Here's my Michigan hint sign, okay? That means that probably this would be a good one just to kind of practice, right? Square root of 3 plus 3. Again, I didn't require it on the homework, but when I do distribute this, I get 3. I'm just going to throw it out here. 3 root 3. 3 times 3 is 9. Square root of 3. times negative square root of 3 is negative 3. And negative 3 square root of 3. Okay, coming back there. On the top, I get 3 plus 3 root 3 plus 3 root 3 plus 9, right? And so if I simplify this, these cancel, giving me 6 on the bottom. And on the top, I would get 6 root 3 plus 12 all over 6. I can divide all 3 of these by 6 here. And what I would get is square root of 3, plus 2 all over 1. Okay. Wow. Or square root of 3 plus 2. All of that right there from here on, got me? That right there is a good one for an extra one on that test. But I wanted to give it to you and just see it and go from there. All right? All right. We are getting on our way here. We're going to do just a couple more. Ones that I would really highlight. Number 2, on HW. Highlight that. Don't look at those. This one, the ones that are like this, where this is the formula of sine of u, cosine of v, plus cosine u, sine of v. Take a look at that one, where u is 140, right? And v is 50, right? And so what this is this formula is actually equal to, if you looked on your formula sheet there, sine of u plus v, where u is 140, v is 50. So if I were to simplify, this is the easier one where I'm going backwards to where I get sine of 190. That would be my answer. Right? That would be my answer. Now, last one that I want to look at is, that's a good one, 19, okay? Or ones like 19. Any one of these, 18 and 20 are very similar. All of these involve changing it from radians to degrees. So we're going to multiply by 180 over pi. In fact, no, I'm sorry. This one you could actually check out on your homework. I think it's the exact one. 5 pi over 12 is not. So we're going to do 5 pi over 12, multiply by 180 over pi. Pi's cancel. 12 goes into 180 60 times. 60 times 5 is, 6 times. 6 times 5 is, hold up. Oh, I'm sorry, this is 15. 15 times 5, my fault, is, this is 75, right? So two angles that added equal 75 are 30 and 45, very similar to the one on the front with tangent. Remember with sine, we put our formula down, which is sine of u, cosine v, plus cosine u, sine of v, okay? In plugging this in, we remember that u is 30, and v is 45. U is 30, v is 45. So sine of 30 degrees, look at that, 1/2, right? Cosine 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And sine of 45 is 1. So now we can distribute these. Square root of 2 times 1. We can multiply across to get square root of 2. 2 and 2 make 4. Square root of 3 times 1 is square root of 3. And 2 times, obviously this is 1 on the bottom. 2 times 1 is 2. Okay? All right. Hold up. This should be square root of 2 over 2. My fault. This should be right here. I was like, what's going on? So my fault. I put 1. Should be square root of 2 over 2. I was thinking tangent. So this would be square root of 6 over 4. And my answer when combined would be square root of 2 plus square root of 6 all over 4. Okay? All right. This right here was our podcast. Man, I hope that was helpful for you. We hit a lot of different problems today. And the ones that I gave you at the beginning, I tried to hit a lot of the hard ones. But I can only guess that there's some problems or questions that you have off the homework or within other problems. Ones like the triangle one, you need to know how to do on the homework, but that is not on the test. The ones that I gave you are really, really sufficient for that test that's there. I hope that helped you, and I hope if I can be of any other help to you moving forward that I can do that there. Hope you have a fantastic day. We will see y'all later, and care about y'all. Bye.